Have you ever been stuck at a red light, staring at it, and wondering, how does this thing even know I'm here? It feels like magic, or maybe just really bad luck when you hit every single red on your way to work. But behind that simple red, yellow, and green is a surprisingly complex and fascinating system that keeps our cities moving. Today, we're going to pull back the curtain and reveal the secrets of how traffic lights actually work. From the simple timers of the past to the smart, AI-powered systems of the future, get ready to see your daily commute in a whole new light. So, how do traffic lights decide when to change? It's not just one single method, it's a combination of different technologies, each suited for different types of intersections. The most basic and oldest type is the fixed time controller. Think of it like a simple kitchen timer. These lights run on a preset, repeating cycle. For example, the main street might get 60 seconds of green, and the side street gets 30 seconds, over and over, all day long. This system is predictable and cheap to install, which is why you'll still find it in many places, especially in areas with very consistent traffic flow, or in smaller towns. The downside? It's not very smart. It doesn't care if there are 100 cars waiting on the main road and 0 on the side street. At 3 a.m., when the streets are empty, it will still dutifully cycle through, making you wait at a red light for no one. It's inefficient and can cause unnecessary delays, which is why cities have been moving towards more dynamic solutions. This brings us to the next level up, actuated or demand-based traffic lights. These are the lights that can see or feel that you're there. Have you ever noticed dark, rectangular or octagonal lines cut into the pavement just before the white stop line? Those aren't just cracks in the road. They are inductive loops. These are essentially giant metal detectors buried under the asphalt. When a large metal object, like your car, drives over the loop, it changes the magnetic field. A sensor connected to the traffic light controller detects this change and registers the presence of a vehicle. This tells the system, hey, there's a car waiting here. So, if you're the only one at an intersection in the middle of the night, the loop sensor tells the controller to change the light to green for you much faster than a fixed timer would. This is why sometimes pulling up a little too far or not far enough can leave you stranded. Your car needs to be right over that loop to be detected. Motorcycles, being smaller, sometimes have trouble triggering these, which can be a real headache for riders. But what about those intersections without the telltale loop markings? Many modern traffic systems are now using video cameras. Look up at the traffic pole next time you're waiting. You might see small cameras aimed at each lane. These aren't for catching you running a red light, although some systems can do that too. Their primary job is traffic detection. Using advanced image processing software, these cameras can identify vehicles waiting in a lane and even count how many there are. This video detection has several advantages over loops. It's less disruptive to install because you don't have to dig up the road. It's also easier to maintain and can be reconfigured remotely if traffic patterns change. The cameras can even distinguish between cars, trucks, and bicycles, allowing for more sophisticated traffic management. On top of video, some systems use radar or infrared sensors. These work similarly by bouncing waves or heat signatures off vehicles to detect their presence and speed. They are particularly effective in bad weather conditions like fog or heavy rain, where cameras might struggle. Now, detecting a single car is one thing, but what about coordinating an entire city's worth of traffic? This is where it gets really interesting. Many cities use what's called a coordinated traffic signal system. The goal is to create a green wave. This is the beautiful phenomenon where, if you drive at a specific speed down a major street, you'll hit a continuous series of green lights. This isn't just luck, it's a carefully choreographed array of data. Engineers study traffic volumes, speeds, and the distance between intersections. They then program the traffic light controllers along the corridor to coordinate their timing. The lights are offset from one another so that a platoon of cars released from one intersection arrives at the next one just as it turns green. This maximizes the flow of traffic, reduces stops, and cuts down on both travel time and vehicle emissions. Of course, creating a perfect green wave is tricky. It usually only works best in one direction at a time, often favoring the rush or commute direction. But we're now entering an even smarter era: adaptive traffic control systems. These are the brainiacs of the traffic world. Instead of relying on pre-programmed timing or simple vehicle detection, these systems use real-time data to make intelligent, second-by-second decisions. They gather information from all the sensors we've talked about: loops, cameras, radar across a wide network of intersections. All this data is fed into a central computer system. This system uses complex algorithms, and sometimes even artificial intelligence, to analyze the entire traffic grid. It can see a traffic jam forming 3 blocks away and adjust the timing of the lights upstream to reroute or slow down approaching vehicles, preventing the jam from getting worse. It can prioritize a bus that's running behind schedule by giving it a longer green light. It can coordinate with emergency services to create a clear green light path for fire trucks or ambulances, which is what happens when you see all the lights at an intersection turn red except for the direction the emergency vehicle is coming from. These systems are constantly learning and adapting to the ever-changing flow of traffic. The result is a much more efficient, responsive, and safer road network for everyone. And the future looks even more connected. With the rise of smart cars and vehicle-to-infrastructure, or V2I, technology, your car will one day be able to communicate directly with the traffic light. Your car could tell the intersection, "I'm approaching and will be there in 15 seconds, and the traffic light could respond, "Slow down to 30 miles per hour, and I'll be green for you when you arrive." This will eliminate the need for many physical sensors and allow for an incredibly precise level of traffic management. Imagine a city with no unnecessary stops, perfectly optimized traffic flow, and dramatically reduced congestion. It might sound like science fiction, but the foundations for this technology are being built right now. So, the next time you're waiting at a red light, take a moment to look around. See if you can spot the loops in the pavement or the cameras on the poles. You're not just waiting for a light to change, you're interacting with a complex, intelligent system that's working hard to get you, and everyone else, where you need to go safely and efficiently. It's a hidden world of technology that we interact with every single day, and it's only getting smarter. Thanks for watching. If you found this deep dive into traffic lights interesting, be sure to hit that like button and subscribe for more videos where we uncover the hidden engineering of our everyday world. Let us know in the comments what other everyday technologies you're curious about. Stay safe on the roads, and we'll see you in the next one.